Hello, GED students. Today's virtual algebra class is on the concept of writing equations of parallel lines. So we've been writing the equations of lines quite a bit lately. Our last two classes have been about this. The first class, we learned to write equations of parallel lines when we were given a slope and a y-intercept, whether we were given them in symbols and words or we were given them on a graph. Either way, we were able to write equations that way. Then last class, we looked about writing equations when we were given points, writing the equations of lines when we were given points. Today, I want to look at how you write the equation of a line when you know what it's parallel to, So in order to do that, I've got to back up. We've got a vocabulary word that we just can't get around. We have to know what parallel means. Okay, so two lines are parallel if they remain the same distance apart no matter where you go or travel on the line. They're always the same distance apart. Another way to think about this is they never touch. You could continue these lines on and on for forever and they'd never ever touch. So you can look down at this first graph that I've given you. I have a graph here with some parallel lines on them. And like, for example, if you were to look at this red line and this blue line, if you were here, if you measured how far apart the red and the blue line were there, or there, or there, or there, this red and this blue line always remain the same distance apart. And I hope that you could imagine that even if they stretched off into space for forever that way, up, or forever the other way, down, they would never meet. You'd have to have a really large piece of paper. We call that a plane. This flat, two-dimensional surface that we draw lines on are called a plane. But so think of a plane like a piece of paper, but even if you had the largest piece of paper, the largest plane you could possibly imagine, you went on and on and on forever, these two lines would never meet. And that is what I mean by them being parallel lines. Okay, so let's clear this out and let's take a look at this little graph a little closer. Before we talk about writing the equation of parallel lines, I have to make sure that you remember a key concept that we've been working on in this graphing unit. So let's take a look here. Okay, my question is if you remember how to write the equation of a line when you're looking at the graph. Do you remember how to write the equation of a line when you were looking at a graph? Well, we had said when we were looking at a graph, we could bust out the slope-intercept equation of a line, y equals mx plus b, the slope-intercept equation of a line. And we told ourselves we don't even have to have this sucker memorized because this guy is on the GED formula sheet. But what you do need to know, you don't need to have it memorized, but you do need to know what these letters mean. There's a whole lot of letters in this equation. Well, when they're all letters, y, m, x, b, what you have is the very general equation of any line. But if you want to get the specific equation of a specific line, what needs to happen is you need to replace the m and the b with numbers. And we know what the m and the b stand for. We joked around that mathematicians were not very creative at all. They named this the slope-intercept form because the m was the number for slope. And the b was the number for the y-intercept of a line. So all we have to know in order to use this equation to write our equation of a line is to know the slope and the y-intercept. Well, both of those things are easy enough to take off of a graph. So let's look at our first line, the red line. I want to look at its y-intercept first. Its y-intercept, or its b. So let's bust out the color red. Okay, so we're looking at the red line. And the first thing I want to look at is its y-intercept, or b. Now remember, what the definition of a y-intercept is. The definition of a y-intercept is where our line, there's the line we're considering, this red line, crosses the y-axis. The y-axis is this vertical axis that runs up and down on our graph. So where does my line cross the y-axis? It seems to cross at this point. And what point, what was that? I just wrote over my number, but that's where y is 4. See that 4 right there? And so that means the y-intercept of my red line is 4. So B is 4. So I have one of the two pieces of information I need to use the slope-intercept form. We said we needed the intercept, but we also need the slope. Now remember, to find slope, or M, off of a graph, you just count the rise, how much your line is going up or down, over the run, how much your line is going over. And you can start from any point on the line and go to any other point on the line. I think I will start right here. That's a point. And it's on a nice perfect corner, and I'll go to right there, also a point on a nice perfect corner. Now, we've talked about this before. This is just a wisdom principle, okay? This is not a hard and fast rule, but a really good wisdom principle is to start from a point on the left and to go to the right. Students make less sign errors when they do things that way. So that's the way I'm gonna do, because I don't like sign errors. Okay, so first you can see that my line isn't really going up at all. My line is going down. If I wanted to go from this point to that point on the right, I would have to go down, not up. And how far did I go down? Well, I started at 4 and I went down to 0. So that's 1, 2, 3, 4 jumps down, of course. Now notice I did not go up, I went down. So that is a movement of -4. How much is my rise? I went down 4, so I have a rise of -4. Now let's think about my run. How far am I running? Well, starting from 0, I ran 1, 2, 3, 4, 5, 6. I ran 6. And so my rise over run happens to be, in this case, -4 over 6. But I did warn you guys quite a bit that you should make sure that all final fraction answers are reduced, which is part of the simplifying process, reducing fractions. But I will do that in my TI-30 excess calculator because I'm so lazy. I will type the fraction bar n over d, and then I will type -4, arrow down to the bottom of my fraction, and type 6. Now you'll notice here, I'm going to press enter, and I do get -2/3. But just a real quick talk, if your answer doesn't look like mine, it's possible that you could be in the wrong mode. If you're in classic mode, you're going to have a fraction bar that looks a little different than mine. No big deal if you are, but I like to do fractions in math print mode. So to switch your modes in your calculator, you hit the mode button. Then to make sure that you're in math print mode, which is very, very handy for fractions, arrow over until you're blinking on the word math print and press enter. Then you can leave that screen by pressing clear. And now your fraction should work like my fraction with the nice horizontal fraction bar. Okay, great. So like I said, there were two things I needed to get the equation of my line. I needed the y-intercept, the b, and the slope, the m. I have both of those things, and so I can write the equation of the red line. The red line is y equals, m is my slope, and I said my slope was -2/3. X will stay x in a line. You always have a y and an x still there. That's what makes it this diagonal line like this. And then I'm going to add onto that my b, and my b here is 4. So I put +4 since it's +4. And that would be the equation of the red line. Now let's examine our blue line. I'm going to start moving a little faster here. Now looking at my blue line, again, I need two things. I need my y-intercept, or my b. The place where my line crosses the y-axis is a b, this time of 0. And now let us examine here the slope of this particular line. These two lines are parallel. We already discussed how they were parallel, and I'm wondering what its slope is. So Again, you can go from any point on your line, like I could go from here to any other point on your line. So I could go to like there. Don't think like there's one right place to go. So I'll do that from there to there. You say, why didn't you do the other one like you did last time? I'm just trying to prove to you that it doesn't matter what point you start at on your line or end out on your line, you'll get the same slope. So we can see on this guy, I'm dropping again, I'm going down. Now, how much did I go down? I went down 1, 2. That's a rise of -2. And then I went over 1, 2, 3. That's a run of 3. And if you're mad at me right now because I don't seem to be counting boxes, I'm not using the boxes to determine where I'm at. I'm using the numbering on my number line. If this is 2, then this is 3, this is 4, 5, and 6. Okay, so I went down 2, I went over 3. That is a slope of -2 over 3, or -2/3. Now you could type this into your TI-30XS if you wanted to. -2, oh, sorry, I was doing the fraction bar first. Fraction bar -2, arrow down, type a 3, and you would see, of course, that is just -2/3. That one's already reduced. If you're the ninja who can reduce fractions without your TI-30XS, you'll save time on the GED. So I'm going to write the equation of the blue line. Once again, I seem to have a slope of -2/3 x, but this time I'm crossing at 0. Now guys, could I write +0? Of course I could write +0, it's true, but I won't because I'm a lazy mathematician. Mathematicians never write an unnecessary symbol. -2/3 x plus 0 is true, but it's not simplified. I know that adding 0 always does nothing, and so I will never bother to write the +0. Okay, so the blue line's equation is just y equals -2/3 x. Cool. Let's go figure out the green line's equation. Again, we need 2 pieces of information. We need to know the y-intercept, the place where my line crosses the y-axis. Here we can see that the y-intercept is at -2. We also need to know the slope. And again, you can start at any point and end at any point, and you'll be able to get slope. I mean, I could do it nice and giant like this. I don't know why I'd want to. It's a lot of work, but I could. So let's count this one. I'd be going down -1, 2, 3, 4, 5, 6, 7, 8. Okay, down 8. And over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I could go over 12. Okay, so that is a rise over run. So a rise of -8 because I went down 8, and a run of 12 because I went to the right. 12, right, is the positive direction. Now, again, remember that final fraction answers must be reduced. So in my TI, I type the N over D button. I type -8 on top. I type 12 on the bottom. Or if I'm good at fractions, I've reduced it long before you've even picked up your calculator. And when I press enter, I get -2/3. So on this one, I have an M of -2/3. I have a B of -2. So what would the equation of this line be? Y equals, well, you always do your M first. So -2/3. I shouldn't say you always do your M first, but you always write it first when you write out the equation. X plus B. Well, this is not a plus B because this is actually a -2. So plus -2 is the same as -2. So a mathematician, if it's a negative, will just write -2. Okay, -2/3 x minus 2. Okay, one last line we're going to look at. That's that orange line right over there. So let me get all my green stuff out of the way. Oh, I don't have an orange on in my color choices. You guys are going to have to deal with pink. Okay, so looking here at my crossing point, my y-intercept, also called the B here, I'm crossing halfway between -6 and -8. I must be at -7. And then looking at the slope on this guy, maybe you figured out by now that it's fun to be lazy, so we should go from an easy point to another easy point. So I'll go from here to here, left point to right point again, because I don't want to make sign mistakes. So I go down 1, 2, 3, 4. I went down 4. And I'll go over 1, 2, 3, 4, 5, 6 over 6. So my slope is going to be my rise, which in this case is actually a fall, -4. Over my run, I went and ran 6. And again, if you were to reduce -4 over 6, you would get -2/3. So here my B is -7, my M is 2/3, and so I can write the equation of my line. Y is equal to -2/3 x minus 7. Okay, that was a lot of do you remember? You might be going, Kate, I thought we were going to talk about writing the equations of parallel lines. Well, yeah, but did you notice it? Did you see what happened? What do you notice about these parallel lines? What do they have in common? Do you see it? I hope you noticed while I was doing it. I felt like a broken record because I kept finding the exact same slope over and over and over again. Of course, parallel lines have the same slope. That's why they never run into each other, because they're at the exact same angle. They have this exact same steepness. So forever and ever and ever and ever and ever, they're just going to keep running like that, parallel to each other. So what do parallel lines have in common? They have the same slope. We saw every single one of our lines had a slope of -2/3. Did you notice that? -2/3 x, -2/3 x, -2/3 x, -2/3 x. Okay, but slope wasn't the only thing we looked at when we looked at our lines. What was the other thing that we looked at? Well, we looked at the y-intercept. So I have a question for you. Did all these parallel lines have the same y-intercept? No, of course they didn't. One of them crossed at 4, and one of them crossed at 0, and one of them crossed at -2, and another crossed my y-axis at -7. Just because they're tilted at the same angle doesn't mean they cross at the same place. Okay, so they did not have their y-intercept in common. I'm going to use the letters too. So they had the same M, but they did not have the same B. What was not in common? The B. So what's the rule? The rule that you have got to walk away from this lesson with. If you take nothing else, if you forget everything else, even all the funny, amazing, wonderful things that I say, you have got to remember that parallel lines have the same slope. And that is exciting news because every equation of a line that we have has slope in it. So you remember, hopefully from last class, we looked at our GED formula sheet and we saw that on the GED formula sheet, there were 2 different forms of the equation of a line. We had what's known as the slope-intercept form. And I'll just write it here, the slope-intercept form. This one you've already seen 4 times today, so it won't surprise you. And we called it the slope-intercept form because it showed us the slope, the M, and it showed us the y-intercept, the B. But we learned about another equation of a line last class, and that is known as the point-slope form. Mathematicians are notoriously lazy. We will always go the easiest way possible. The point slope form, again, you don't have to have this memorized. It's written down on the GED formula sheet, but it is y minus y1 is equal to m times the quantity x minus x1. And what I want you to notice about these 2 formulas is what they have in common. They both have the word slope in their title, and they both have the slope in their formula. That means no matter which way we go to write the equation of a line, we have got to know the slope. I say that again, no matter which formula we choose, we have got to know the slope. It's like our first step when we're writing equations of lines. Okay, let's do some example problems armed with the knowledge that we have now. Example 1 says find the equation of the line that is parallel to the line y equals 2x minus 1 and runs through the point 0, -5. Now notice, again, just like before, they've told me to find the equation of the line. We just said you have a choice. When you're told to find the equation of the line, we currently know 2 forms of that. We know the y equals mx plus b. The slope-intercept form, or the y minus y1, equals m times the quantity x minus x1, which is the point slope form. Whichever one of these we use is going to depend on what we've been given. So let's look at what we've been given. What do we know? Well, we know this fact. Our line is parallel to this line. Y equals 2x minus 1. And we just discovered something about parallel lines. 2 minutes ago, we looked at these parallel lines. They all had something in common. Parallel lines have the same slope. Well, what is the slope of this particular line here? I know since my line is parallel to this line, I can steal this line's slope. So what is this line's slope? Well, we remember hopefully that slope is the m. I call slope Mrs. X because she's always shoved up against that x, multiplying with that x. So I can see that the slope of this line is 2. Since my line is parallel to this line, my line will have the same slope. But don't do the beginner's mistake that everybody else does. They go, oh, and there's my B. And there's my B. Well, we just said that. Parallel lines didn't have the same B. They don't cross at the same place. They just have the same slope, the same angle. So don't use that y-intercept. That's like a distractor. Just steal the slope. Okay, so there you go. That's like our motto for today. Just steal the slope. Pretty sure your GED teacher is not supposed to encourage you to steal, but we're just going to steal slope. Probably no harm done, okay? No harm done. So we're going to steal this slope. Now, this is another thing we've been given. Now, you say to me, I'm like, what is that other thing we've been given? Obviously, it's a point. I know that this is a point. So could I use point slope form? I absolutely could. I could go straight to here and use point slope form, and you might do that. But I'm going to notice something about this point. This isn't just a point. This is a special point. I hope you watched last class's video to get this explained to you. If you didn't, go back and watch it because I'm not going to take another 45 minutes to do the same thing. But we learned when you had a 0 in the x coordinate, then a point was a very special point known as a y-intercept. This is the y-intercept, which means I can also see my b. My b is -5. Remember, b is the letter we use for y-intercept. So since this is a 0, this is my b. Hallelujah. Right there, that means I know my m, I know my b. I can plug into the y equals mx plus b formula. And that's what I'll do. I'll plug in my m. My m was 2. I'll plug in my b. My b is -5, so I'll write -5. And what's the equation of that line? Super simple. I could see everything. It might not have been as obvious, but I could see the slope because my line's parallel. They'll have the same slope. And I could see the y-intercept because I know that y-intercepts have an x coordinate of 0. Great. Super simple example. Let's look at another simple example. Example 2 says find the equation of the line that is parallel to this line. So what does it mean when lines are parallel? Steal the slope, baby. I'm about to steal the slope. I can steal the slope. Parallel lines have equivalent m's, so that means that my line's slope will be -4/3. Remember though, don't go stealing the y-intercept. The b's are not in common, just the slopes, just the m's. Okay, now I do need the b though. If I've been given it, let's take a look here. It says find the equation of the line that is parallel to the line, yada, 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 and runs through the point 0, 0. So again, I've been given a point. And I would ask you, is this the point that's a y-intercept, or is this just some other point that they've given me? And the way you can tell, the test for that is you look at that x. Is that x a 0? It sure is. So check. That means this is the y-intercept. So I come over here to the y value. That's my y-intercept. So I know my b is going to be 0. Okay, so I know my m, I know my b. That means that I could use the slope-intercept form, the y equals mx plus b form. So y equals -4/3 x. Now I can write plus 0. We've talked about this a lot. I could write plus 0 because I know the y-intercept is 0, but I'm a lazy mathematician who never bothers to write down anything that won't do anything. And I know that adding 0 does nothing. And so I'm going to use the simplified form of this equation and just write y equals -4/3 x. That is my final answer. It is, they asked me for an equation of a line. That's an equation of a line. Okay. Now, we've been talking that there were 2 different equations of lines. I mean, we had 2 up here. How come Kate just keeps choosing the y equals mx plus b? Well, the reason I was choosing the y equals mx plus b is because I have been having these problems where I knew my slope and I knew my y-intercept. So this is the easy way to go. Let's look at the next problem. A little different. Once again, I do see here, let me just erase this extra line. Okay, I do see here that the directions appear at first to be the same. Example 3 says, find the equation of the line. And again, I'm given some information about my line. 2 little clues. You'll pretty much always have 2 clues. Okay, this first clue is that my line is parallel to y equals -3x minus 5. And remember what it means to be parallel. Parallel means you slope at that same angle. You share a slope. So we're going to steal the slope. M equals -3. And we're going to ignore the rest. That's all we care about. Okay. But then notice what I have here. We also know that it runs through the point 2, 5. So my line goes through that point 2, 5. So I have a question for you. Is this the intercept? Is this the y-intercept? Well, let's evaluate. Look at the x coordinate. At the intercept, the other guy is always 0. So at the y-intercept, the x will be 0. Is that a 0? No. So they didn't give you the same kind of information this time. They didn't give you that special point, the y-intercept. This is just any old point. This is not the y-intercept because that's not a 0. Let me just take good notes for you. This is just a regular plain old point. So this time I know my slope and I know a point. It would probably serve me best to use the other equation I've been given, the point slope form. Now I have a secret to tell you, and a lot of new math students don't like this. On the other problems, I could have used the other equation. And on these problems, I could even use the slope-intercept equation. I just have to know how to properly use it. So there's not one right way to do math, okay? But I had to choose a way for this video. So I choose the way that's easiest, I think. When I have a point and a slope, I'll use the point slope form, okay? So I'm gonna bust out the point slope form. Y minus y1 equals m times the quantity x minus x1. It's funny because my students always get mad at me when there's more than one way to do something. I'm like, that's powerful. And they're like, that's confusing. Sorry, that's life though. There's more than one way to do a lot of things. Okay, but anyway, I'm going to take this thing and plug into it. Now remember, just like with the y equals mx plus b, right now this is the general form for any line. I haven't put any information into it yet. It's not a specific line. I've got to plug in numbers, but in the point slope formula, you plug in 3 numbers. You plug in your slope, your m, but you're going to plug in both your x and y coordinates of your points, and that's the x1, y1. That'll be the x coordinate of your point and the y coordinate of your point. So let's go ahead and substitute into this formula. So I won't change my y or my minus, but I will pick up the y coordinate of my point. The y coordinate of my point was a 5. Okay. And that'll be equal to, and I will plug in my m. My m here was -3. I will keep my parentheses because they're telling me about a grouping. I'll keep my x and my minus, but then I will plug into my x, 1. My x1 is my x coordinate of my point. So come over here to your point and look at what's in the x place. Remember, points are x, y. So x comes first in the point. And that's a 2, so I put a 2 in there. Now, the nice thing is that you can start with either the point slope form or the slope intercept form, but you should put your final answer into slope intercept form. And again, we did this like 8, 9 times in the last class, so I will do it a little quickly. If you didn't get to see it, you might want to go back and see the last class. But it takes just 2 steps to take this sucker right here, the point slope form that's been plugged into, and turn it into the slope intercept form that we usually write our final answer in. And those 2 steps are pretty typical of algebra. They're simplify and solve. Simplify, do any forwards work that you know how to do, put numbers together. Solve, isolate, okay? Get letters alone. And so I see some simplifying I can do right here. -3 is shoved up against these parentheses. That means -3 is multiplying by everything in the parentheses. So I will do that, simplifying first. I will pass out the -3. So -3 times x is -3 times x. And -3 times -2 is +6. And there's no simplifying to do on the left-hand side, so I will just drop my left-hand side, y minus 5. Now I'm almost done, but I need to solve this equation. And you might say, Kate, I can't solve this equation. There's 2 letters. Solve doesn't mean find out what number we're equal to. That does sometimes happen. But solve means get the letter alone. So when I say solve this equation, I mean solve for y. Y is always alone in the slope-intercept form of equation. So I'm going to do the opposite here of subtracting 5 so that I can get rid of this 5 that's hanging out with y. I'm going to add 5. And the rule of solving is I can do whatever I want as long as I do it to both sides of my equation or inequality. So I'm going to add 5 over there as well. And I wish I had left myself a little more space so you guys could see me going right underneath. But subtracting 5 and adding 5 cancel, so that all that will be left on my left-hand side is y. And on the right-hand side, I didn't combine anything with my -3x, but +6 and adding 5 to +6 gives me +11 or +11. And so this is my final answer. Y equals -3x + 11. Great. This is as complicated as this is going to get. I'm just going to look at a few examples that tend to trip students up, and then we'll be done for today. The greatest thing I think probably about being a YouTube student or a video student is you can be done whenever you want. You don't have to wait for me to be done. It's great. My classroom students wish that they had that luxury, but they don't. Sometimes they just tell me they have to go to the bathroom a lot. I bet that's a way to get away from my voice. Okay, so example 4 says, find the equation of the line that is parallel to y equals 5/2 x minus 4. So again, what does parallel mean? It means it slopes at the same angle. So we'll steal the slope and ignore the rest. So the slope of my line will be 5/2 and contains the point -4, 3. Is this point an intercept? No, it's not. I'm gonna have to go the long way. I'm going to use this point slope form because I know the point and I know the slope. Okay, I look at my GED formula sheet and it tells me that the point slope form of a line is, I think I learned my lesson last time, I'm going to write a little smaller, y minus y1 is equal to the m times the quantity of x minus x1. And I will plug into that, keeping y the same and the minus the same. Remember that the y is the y value of your point. So in this case, it'll be 3. And that will be equal to the m. The m is your slope that you just found, 5/2. You stole that from the other line because they share a slope if they're parallel. X minus, and of course my x1 is my x value of my point. My x value of my point is -4. I want you to notice something. This irritates a lot of students. There was a minus in my formula, so I wrote minus. but there was also a minus on my 4 because it was a negative 4. So I write both of those minuses. And you might say, Kate, I can't minus minus, and that's okay. We'll deal with that. We're supposed to know what happens when you're minusing a negative number, but I'm going to write it before I deal with it, okay? Too many students just drop a negative to deal with it, and that's the improper way to deal with it. What you need to realize now is that the opposite of subtraction, that's another way you can read a minus sign, opposite. So the opposite of subtraction is addition, or conversely, you can think of it as the opposite of negative is positive. So these two minuses right in a row turn into a plus. That's the same as x plus 4. And now that we've dealt with that little negative dilemma, we can do the same 2 steps to simplify and then solve. So I will start by simplifying. That 5/2 is shoved up against the parentheses, so it is multiplying. Now students tell me all the time, oh my dear Lord, Kate, I cannot multiply fractions. First of all, by the way, y'all are scarred for the wrong reasons. It's actually really, really easy to multiply fractions. Can't wait till I teach you that lesson. But especially in algebra class, if you want to multiply a number and a letter together, you just shove them together. 5/2 times x is 5/2 x, okay? So I'm going to write that. But remember that multiplication passes out over parentheses. That's known as the distributive property. So I'm going to have to also multiply the 5/2 times 4. Now that's actually really a super simple one to do in your head if you've done multiplying fractions before. But since I haven't taught this to my class yet, I'm going to assume all you students on the internet haven't learned it yet either. So I'm going to do that 5/2 times 4 in my calculator. So to do that in my calculator, I'm going to bust out that n over d bar again. I'll type 5 on top, arrow down to type 2. Now it's super important when you're in math mode that you get out of the fraction before you type the times. If you type times right now without arrowing out, you're only going to be timesing the bottom of your fraction, but you want to times the entire fraction. So I arrow out and I press times or parentheses. Well, I'll just do times 4. And it tells me that it is just 10. You're like, really, Kate? It's just 10? Yeah, I promise it's just 10. Now on my other side, I have y minus 3. Great. So I did the first step by simplifying. The left and right hand side of these problems are simplified. And now I want to solve for y. I want to get y alone. So in order to solve for y, to get y alone, I'm going to have to get rid of this minus 3. So I'll do the opposite. I will add 3 to both sides of the equation. Okay. On the left hand side, subtracting 3 and adding 3 cancels so that my y is alone like I wanted. I didn't combine anything with my 5/2 x, so it's still 5/2 x. Ooh, that's hard to say. And then positive 10 plus 3 is, of course, positive 13. And that is done. That is the equation of that line. And I know I'm done because y is alone. You want your final answer in slope-intercept form, so y should be alone. Okay. No, I'm using a ton of math language, and that's probably the hardest thing about all the graphing series. It's so much unfamiliar language to students. So I want to use these words over and over again so you get familiar with it. Okay, 3 more examples and we're out of here. Okay, number 5 again asked me to find the equation of a line. So I'm thinking to use one of those equations of lines that I have on my formula sheet. And again, it gives me 2 pieces of information. I know my line is parallel to y equals negative 3/4 x. Remember, parallel means you can steal the slope, and there I see that slope, negative 3/4 x. She's all shoved up against x, so you know she's a slope. Mrs. X, I call the slope. So I know Mrs. X, or the slope, is negative 3/4. And contains the point, 12, negative 2. This is just a regular straight up point. There's no 0 in the x value, so it's not an intercept. And so I know that I'd like to use the point slope form on my line. I will plug in the y value, negative 2. The m, my slope, was negative 3/4. And the x value of my coordinate, I'll put in under x1, and that was 12. Okay. Again, I will deal with minus minus to simplify the left-hand side. To simplify the right-hand side, I will pass out that multiplication. So my left-hand side is y plus 2, but on the right-hand side, negative 3/4 times x is negative 3/4 x. And negative 3/4 times negative 12, again, you may do it in your TI if you'd like, negative n over d, 3/4, come out of your fraction and multiply by -12. Remember, when you multiply, those addition and subtraction signs act like negative and positive signs. And I get +9. I just get a plain old 9. Since it's +9, but this is a term, you're going to need to put +9. Okay. Now I'm almost done, but my y is not alone. Right now, y is hanging out with a +2, and so I'm going to do the opposite of adding 2. And I tried to do the same, but I want to do the opposite. I want to subtract 2 on both sides. So on the left-hand side, adding 2 and subtracting 2 cancel, so my y is alone. I didn't combine anything with my -3/4 x, so it chills. And +9 minus 2 would give me +7, or +7. And that is my final answer. One more I thought might trick you, so let's take a look here. Look at this tricky little example. It says, what is the equation of the line? So once again, I can be sure I'm writing an equation of a line that passes through the origin. It passes through the origin. Well, do you remember origin is a vocab word we learned, oh my gosh, like 12 or 13 lessons ago, so it's been a while. Origin is that point on the graph where the x and y axes meet. It is a point. What point is it? It's the point 0, 0. So they gave you a point, but they hid it in vocabulary. Watch out for them. And is, oh my gosh, I just realized that I wrote a really stupid problem. Let's pretend like it doesn't say this. I accidentally gave you the same line. You have to pretend like Kate was smarter than she was. Could you please? Okay, so we're going to say that our line passes through the origin and is parallel to y equals -x plus 5. Pretend like it always had a +5. Could you do that for me? Could the whole internet just like collectively imagine that with me? So, and is parallel to y equals -x plus 5. Okay, looking at this sucker, -x plus 5. Remember we said that you can steal the slope when our lines are parallel. Indeed, we got that information that we're parallel to this line. But what is the slope on this line? It just looks like a minus. Remember that the invisible coefficient is 1. When we have 1 of something, we don't brag about it in math class. So that means my slope is -1. Okay, so to write this equation of this line, I know my slope. And I know a point, but it's a super special point. Notice again, my x value is x. This is a y-intercept. You can use your slope-intercept form. Y equals mx plus b. So y equals -1x plus 0. But this sucker totally simplifies. What is -1x? It's just -x. And what happens when you add 0? Nothing. And so the line that is parallel to mine is y equals -x. Now you see where I screwed up. I was like, what line is parallel to y equals -x? And it was the same line. I'm sorry, y'all, it's been a long week. Okay, cool. So that would be the answer there. Now you say, Kate, what if I didn't notice that that was the y-intercept? Like, how am I supposed to remember all this stuff? You talk a lot. I do. It's true that I talk a lot. Let's see what would happen if you had gone the other way. You say, but Kate, what if I had gone the other way? What if I picked up the point slope form? Because that is a point and that is a slope. Okay, well, let's just see what happens. Could you go that way? Let's check. Y minus y1. Well, y1 is my y value. My y value and the intercept is 0. Equals m. My m was -1. So -1 times x minus x1. And my x value is also 0. Well, let's see what happens. First of all, x minus 0. Well, we'll do it just like we've always been doing it, just in case you are a really step-by-step follower. So let's see. -1 times x would be -1x. And -1 times 0 would be, oh, it would be 0. I don't need to write 0. Okay? And then on this side, y minus 0 is, of course, just y. Okay? And then if I have -1x, I'm a mathematician. I never bother to brag about having -1 of anything. I would just end up writing y equals -x. Did I get the same answer? Yes. Doesn't matter which way you go. No, I'm telling you. Good math always works. So if you're freaking out, how am I supposed to remember which one to use? you could just freak out a little less, because as long as you do true statements, either formula will get you in the same place. They're just two different forms of the same thing. Okay, last one and then we're done. I've been asked, what is the equation of the line? I found out that it passes through this thing. What is this thing? Of course, that's a point. Is it a y-intercept point? No, there's no 0 in the x value, so it's just a normal regular point. And is parallel to y equals -2. Now, I really wanted to talk about this because this is what students do to me all the time. They're like, hey, it's parallel, I'll steal the slope. M is equal to -2. And I'm like, you're a liar. Okay, my line is parallel, yes. But that's not the slope of that line. Don't just see a number and assume it's a slope, y'all. Remember, slope is the number that's multiplying with x. Do you see an x next to that -2? Neither do I. That is not a slope. So then you say, well, what's the slope then? I don't see another number. And I'll ask you, how many x's do you see? How many x's do you see in that equation? None. We have a number that means none. 0. I have 0 x's in that equation. So guess what? My slope is not -2, y'all. My slope is 0. Okay? So I pass through that point, I have a slope of 0. So if I were going to use the point slope form, which is how I'd probably go since I have a point and a slope, and I plugged in my y value for my point, that's -7. Notice I have the minus for my equation and the negative in with my 7. My m is 0. And my x -4 for the x1. Okay, now on this side, y minus turned into y plus 7. So that's simplifying the left-hand side. Now let's think about the right-hand side. Come on, y'all, we're mathematicians. I don't care what you times by 0. It could be 5. It could be 55. It could be 3,772. Anything you times by 0, 0 always behaves the same way. It just zeroes things out. So I don't care if I'm taking 0 and multiplying it by this big, huge, ugly number. It's all going to turn into 0. It doesn't matter how gross your number is, how algebraic, how full of letters, how disgusting. If you multiply the whole thing by 0, it's just going to zero out, okay? You could be lazy like a mathematician and save steps. You could be home drinking tea while the B students are still trying to figure out what 0 times everything is. Okay, so we're almost done with this, but y is not alone. Last step, to isolate y, the opposite of adding y is subtracting y, so I subtract 7 from both sides. On the left-hand side, adding and subtracting 7 cancel, so that y is alone like I wanted. And on the right-hand side, 0 minus 7, of course, is just -7. And I get to y equals -7. If you're a math ninja who could have done this problem faster in your head, I congratulate you. But I think this is how most students would go. And we get to the right answer anyway. Okay, brilliant. That's all I got for you today. I have one more lesson in this series and then we'll be done with this series on graphing. Next class, we are going to talk about finding the equations of perpendicular lines. So today we found the equations of parallel lines. How's that gonna change? How does the process change when things are perpendicular? Stay tuned next class and we'll figure it out together. All right. Happy learning, y'all.